Welcome to Chain Reaction, part of this Computer Science 112 course for the University of Idaho's dual credit program. All right, so in the warm-up, we created a bunch of turtles that had different breeds, and we moved them according to their breeds. In this lesson, we're going to be taking that a step different, and we're going to develop a chain reaction program. But first, we need to talk about the different ways that we can add more turtles. We've talked pretty much at this point only talked about one way, so we're going to talk about the other way that turtles can be created. We're also going to talk about global and agent-specific variables. So there are three ways to increase the number of turtles. We have the one that we've been using pretty much entirely the entire time in this course, and that's create. This creates a number of new turtles at the origin, or if we provide them additional content somewhere else, with different headings and a random color. The next way that we have is called hatch. This creates a number of new turtles with each new turtle inheriting all of the variables of the parent except for the who number. So they're kind of being hatched. Like you can think of ducks. Like they are all very similar to the parent. They're just, different creatures. Alternatively, have sprout. And this creates a number of new turtles on a current patch. And you can think of this again. You can almost take the duck approach with this, I guess. Is they have there's the duck nest, and they all hatch, and they sprout from there. Really, is the way that kind of net logo looks like this. They sprout from that one spot. Hatch, I guess, would be better as like kind of idea of like human or something like that having a kid. So we're going to look at each of these in the NetLogo library or dictionary. Sorry. So create, like I said, create dash turtles. You can use CRT for short, but it expects there to be create turtles and then a number. And then you can also do create turtles, a number, and then provide commands after it. You can also apply any breeds. Notice the plural aspect of that for any breeds that you may make in your program. This is the definition from their dictionary. So this is just kind of something that you can look at. So it creates a number of new turtles at the origin. They have random integer headings, and the color is randomly selected. If they use the breed, then it's the same number or same member of the given breed. So if you create wolves, they're not going to be sheep, right? So it's helpful. Hatch. This turtle creates a number of new turtles. Each turtle inherits all of its variables, including its location, from its parent, with the only exception being the who number. And it could be a different breed if the hatch breed form is used. Like so, if you have a wolf and then you have it hatch a sheep, it would be a sheep, I guess, at that point in time. So just got to pay attention to something like that. Sprout creates new turtles on its current patch, and they have a random integer setting, and the color is randomly selected. You can use Sprout breeds, and they will be a part of that specific breed. So create when the variables for the new turtle are random, hatch where they need to be coming from the parent, like cloning, and sprout is when we need them to be on a specific patch. So the next thing we're going to talk about is variables. Variables can be global or be agent specific. A global variable can be used by all of the agents at any point in time during the program. So globals, traps triggered. We're going to use that here in a second. Agent variable is assigned and is only used by that specific agent. We've done this before of turtle's own and patch's own. So we can say, hey, these different agents, remember agents being, we got turtles, patches, link, and observer. This is very much agent specific. And again, you can find more information on this in the programming guide. What we're going to be building today is a chain reaction program. For those of you familiar with physics or chemistry, this is going to be a nuclear explosion recreation idea. We're not actually building a nuclear weapon, but we're seeing what the chain reaction that happens inside of a nuclear warhead or nuclear device is. So you can also see versions of this with the mousetrap. That's another way of kind of showing this. So we're going to have a ball that's dropped on the floor of mousetraps. When it hits that trap, it's going to set off the trap, and it's going to hatch a new ball, and it's going to, and both balls will bounce off the trap and land on other ones. If we land on something that's already been triggered, the ball is going to die or stop. So our beginning plan, we need buttons, setup, step, go. We need a slider for max distance for the ball to bounce, 0 to 10, and we're going to do increments of 0.1. Our setup, we're going to have it clear the screen. We're going to set the patch color to be yellow, set our default shape to be a circle, create a turtle, and whenever we do go, we're going to check if the turtle's on a brown color. If it is, we want it to die. If it's on a trap, it's going to set the trap off the trap. It's going to change the patch color to be brown, and it's going to hatch a new turtle. And then we're going to call the move function. Move is going to make it right turn or random 360 and move forward the max distance. That's the slider. Then we're going to plot what's been going on. So we're going to plot the number of balls, and we're going to trap the number of traps triggered. So let's go ahead and get to this. All right, so I already made my setup button. Let's go ahead and make a couple more buttons. Let's make a go button. Disable until tick start and forever. And let's add another button that uses the go command that has a display name of step and disable until tick start. Let's add a slider. And this is max dash distance. Hopefully you can read that. Yeah. Okay. 0 to 10. And our increments are going to be 0.1. You could put 0.1 if you wanted to. I'm going to make my default value be 5, though, and I'm going to click OK. So far, nothing's going to happen. That's fine. Let's go ahead and let's see here. Anything else I want to include on this? I think not yet. Okay. We'll do one more eventually, but let's go ahead and get this code going first. All right. I need to zoom this in for you guys. All right. To set up, we're going to clear all. Oops. And then we're going to create one turtle. Actually, no, we need to set the default shape first. Set default shape of all turtles. Let's go into here real quick. Let's check and see. Show shapes. Circle. That's the one that we want, circle. All right, so set default shapes turtles to be circle. That already exists for us. Create one, reset ticks, and end. Oh, actually, we wanted to say, also, we're going to ask all the patches. Set P color yellow. Okay, that's our setup. If I click setup, makes everything yellow, puts a little dot right in the middle. Perfect. Actually, let's make this set P color white. It kind of looks nice whenever it's white. Oh, it models the ping pong ball. All right, setup. It's white. Awesome. Oh, it's not P color. Sorry. Color. Check. Setup. There we go. All right. So let's do our go to go. What we're going to do is we're going to check if the, oops, we need to ask for our turtles. Ask turtles. If P color equals, let's do brown, then we want them to die. And I don't know if we really used that. Yeah, I think we did that. Die to be a little aggressive. You're like, and die. No. And then, so we're going to check if it's brown. We're going to check if P color equals yellow. Then we want it to hatch 1. And we can do these as exclusives or as their own separate if statements. You could also make this an if-else statement, but you would be kind of writing in a little bit extra that we don't necessarily need. It is important because we also need to set P color brown. That we have the if it's on P color brown comes before the if it's on yellow. If we did this first and then did this, it would actually not work correctly. So we want this to happen. Then we're gonna go forward max distance, and then that's gonna be the end of ask turtles, and we're gonna pick end. All right, let's see if that works. Setup. Oh, okay. Yes. All right. So what's happening right here is we asked the turtles to do this, but the turtles, this one hatches and it doesn't do anything. It actually doesn't do this until the next time we go through Go, and it runs into this issue. So we're gonna hatch one, and then we're gonna have it. Let's call it move. So I'm actually gonna change this to be move as well. And actually, no, I think it'd be cleaner. So I always look for, make it cleaner. Ask turtles. All right, so let's go ahead and to move. This is already inside of turtle context. So in turtle context, we want it to right turn a random 360, and then go forward the max distance. All right, let's see what that looks like. Setup, go. Hey, all right, there we go. That's looking good. One thing I'm noticing is that continues on after my go's done, but I can clean that up a little bit more. Let's see, we could make procedures out of this actually. So we could say to death. We could take this, put it in here, and so death in turtle context. This one to spawn. Put it all there, and oops, semicolons in turtle context. Check. Setup go. Oh, I messed something up. Spawn. Check. Setup go. Awesome. All right. So let's see. Let's add this. Yeah. Max distance. Oh, ooh, yeah, let's put this in here. So let's go ahead and make it so that then if let's see, I want to use not, oops, sorry. If not any turtles, then we want this whole thing to stop. So if there's no more turtles left, we want to stop. Let's go check it. Setup, go. And it stops our ticks so that we can know, okay, that's how long it took to happen. Because it's checking the number of turtles. Okay. Let's go ahead and add that plot. So let's see, add a plot right there. Yeah, that pops up for you. Let's enable it chain reaction. So this first one, we're going to count the number of turtles. I'd like to do white, but that just probably won't work very well on our screen. So let's go ahead and do yellow. Oops, and close. And then right down here, we can add a pen. And what we need is we want to know how many traps are triggered. So I guess one way we could do this is we could plot count patches with P color equal to brown. Let's see, let's make that brown. 35. Okay. So let's see if that does it. Okay. So that definitely is one way to do it. Another way that we could do this is we could create a global variable. And we can call this global. Globals. And what we want to do is we want to use a thing called traps triggered. Traps triggered. There we go. And what we would do is we would set in this very beginning part, we'd set traps triggered to be 0. Then, if we do make this thing change, if we do hatch something, then we want it to hatch one, set the P color brown, and set traps triggered to be traps triggered plus 1. I think that should work. If I could spell traps triggered right. There we go. And so instead of this chain reaction, I could plot traps triggered. So set up and go. And you see that's a very similar shape. So hopefully nothing too strange and unusual right there. I realize this is kind of small for you guys. Okay. Let's see here. Okay. So your actual assignment in this, at least for my classes, is to finish this reaction program, change the color of your traps to make them unique, change the color of the trigger traps, make them unique, and then add some comments to the whole program to help you increase your understanding. Hopefully this has been helpful.